Okay, we're on the second page of Protractor Practice, getting more into the stuff that we're really interested in with these protractor skills. So we start here with a ray, and we want to draw the normal, which means I'm measuring 90 degrees, and then so I do that again with my protractor, as I talked about last time, about holding it against the edge and then moving it over, holding it against the edge like this is the easiest way to trace that. And then draw the reflected ray. So I need this angle of incidence to equal the angle of reflection. I'm going to have to extend this ray back so that I can measure that. Okay. And then use my protractor, and I get 10, 20, looks like 27 degrees. So I need to go 27 degrees on the other side as well. And something like that. Okay, so there's my outgoing ray. We're going to also do the same thing here. Draw the normal, draw the incident ray. Put the protractor down and draw the normal. The one there, I could draw a normal anywhere here, but the one I'm interested in is the one that intersects the mirror where the ray is that I'm looking at. Oops, a little too far over there. There we go. Okay, and this one's, so we know the outgoing ray, the reflected ray in this case, and we want to find the incoming or the incident ray. So this one looks like it is 10, 20, 30, 40, 55 degrees angle of reflection, so we have to have a 55 degree angle of incidence. So I'm going to place a dot and draw that ray. That's the ray that's coming in. So 55 degrees and 55 degrees. Okay, here we have an object, and we want to find the image. So we have two different ways to do that. We have our shortcut, and then we have our ray tracing. So for the shortcut, we would just draw a line, or we would just go across the mirror. You don't really need to draw this in, but use your protractor to measure 90, and then across the mirror, same distance. Over here you would find it, so you would need a ruler for that and a protractor to make a 90-degree angle. I'm also going to do it with rays, because that's sort of the more fundamental method. So I'll just draw two rays, any two rays that I want. These two rays came from the object and hit the mirror, which means I need to draw their reflections in order to see where folks are going to think they came from. Because I have a big protractor here, I'm going to have to make these come back so that I can measure the angles. So I do the reflection of my first ray. It looks like it has an angle of incidence of right at 30 degrees. So here's my reflected ray. And my next one has an angle of incidence of 20, 30, 40, 50, right about 55 degrees. So I will draw that one as well. Okay, now that I have these two rays drawn, if an observer sees this one and an observer sees that one, each observer knows what line the image lays on, but I have to put the two together to figure out where it really is, so I trace back these reflected rays. This is the first reflected ray. So this observer thinks it's somewhere along this line, so I trace it back, back, back. This observer thinks it's somewhere along this line, so I trace it. Oops, I accidentally deleted that ray. So I trace it back, 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 and these should intersect at a nice point here, these two. And that is where my image is. So that's the place where all observers agree that, you know, hey, it came from over there. And that'll work for everything, not just for plane mirrors, whereas your shortcut only works for plane mirrors. Okay, With our ants here, we want to first find Ellie's image. Easiest way to do that is to measure across the perpendicularly across the mirror. Okay, so that's a line perpendicularly across here, and I just have to measure to see how far we are. And looks like we're right about here. Oops. So that's Ellie's image. And we want to know which ants are able to see this image. There are a couple of ways to do this. We can do field of view with ray tracing, or we can just look and see for which of these is there a path sort of through the mirror. If I look at Annie, there's a path there, so Annie can see Ellie's image. If I look at Archie, that path does not go through the mirror, so Archie cannot see it. Ozzy, it does. And Eddie, it does not. So for these ants that can actually see the image, this is actually the reflected ray. Ellie can see her own image as well. This is the reflected ray. It originally came from Ellie and then bounced off the mirror and then reflected along this path to the person. So we can actually draw really easily those incident rays. And there's no ray that will get to Archie or Eddie. So which ants can see Ellie? So I'm going to say Ellie can be seen by Annie, Ellie, and Ozzy. Annie, Ellie, Ozzy, but not Eddie or Ellie. And because the law of reflection is symmetrical, that goes both ways. So we can say that. Is there an image of Eddie? Yes, there is, even though Eddie is not in front of, directly in front of the mirror. So Eddie can't see his own image, but he certainly has one. So I extend the line of the mirror there. That's just a touch crooked. So let me fix that. There we go. A little crooked still. Sorry, wrestling with the protractor here. Okay, that's better. And then again, measuring across that gap. Perpendicular across puts me right about here. So there is Eddie. And it's right there, so who can see it? If I'm just sort of putting my protractor across here, yeah, Archie can see it. Ellie cannot see it, which we already knew. Annie cannot, Ozzy cannot. It's really only Archie that can see Eddie. Archie can see Eddie, and Eddie can see Archie, but none of the others can see. I'm going to use the other technique for Archie, so I'll get some of these rays out of the way. So for Archie, I'm going to look for field of view, the ants that Archie can see. So the ray that's coming from the end of the mirror is this one, and then the ray that's coming from the other end of the mirror is this one. And if we figure out where those rays came from, again, my protractor's big, so I'm going to trace it back with dotted line and dotted line so that I can measure the angles. If I figure out where those rays came from, then I figure out what you can see at each edge of the mirror. If I figure out what you can see at each edge of the mirror, then I can figure out my field of view. So that ray came from like here. And this ray came from So the field of view is everything in here. So it looks like Ellie's right on the edge of it, which is well, it's just a touch different than what we had before. So it looks. Let me remeasure my angle. Okay, make sure that everything's okay. 53. Oh no, it's just a little bit too far to the side. So our original result was correct. Cannot see Ellie. And looks like he just misses Ozzy too. So Ozzy's right on the edge there of being able to see or not being able to see. So in the field of view, it looks like I really just have Eddie for Archie. And then we just need to do this for really Annie and Ozzy. Will get us everything. If you do the either method here, we'll see that Eddie can not see Archie, can see Ellie. We need to, Annie can see herself, and Annie can see Ozzy. So the ones that work here, if I can just color this in so you can see. So those are the ones that can see. And we have two different techniques for doing this, the images method and then the ray tracing off the edges of the mirror. We'll answer any of these questions here.